We are now getting into polyhedrons. So we've talked before about polygons. Polygons were two-dimensional and they were many-sided two-dimensional shapes. Polyhedrons are many-sided three-dimensional shapes. So polyhedron, solid 3D shape that is bounded by polygons. So each face is going to be one of those two-dimensional polygons, and they make up polyhedron. And the polygons that are around the sides are called faces. So to remember that, a lot of times I will draw a face. Say that is a face on that particular polyhedron. The segments where the faces meet are called edges. So edges are places where faces meet. If you were going to build a polyhedron, you might need something to construct with. The place where you would put the glue to hold the faces together, the glue would be on the edges. The points where the edges meet are called vertices. And vertices is a fancy word for corner. So vertices are the corners, the places where multiple edges meet up. Find the number of faces, edges, and vertices for the figure at the right. So the figure at the right, which is our rectangular prism over here, it's going to take you 6 faces. Front, there's a matching back. Top, there's a matching bottom. Right, there's a matching left. So 6 faces. Also, you could think about rolling a die, or you could think about a cereal box, and those might help. Edges. Well, you can notice that I colored in 4 green edges along the top. There's also going to be 4 green edges along the bottom. And then there's going to be 4 green edges connecting the top to the bottom. So there are 3 sets of 4, which would be 12 edges. And last, vertices or corners. I've highlighted a single vertex here. 1, 2, 3, 4 vertices around the top. There would also be 1, 2, 3, 4 vertices around the bottom, making a total of 8. You probably also just heard me call a singular, right, vertex. If you're just talking about one, it's a vertex. Plural, multiple ones are called vertices. There are 2 common types of polyhedrons, prisms and pyramids. So the one we were just looking at is a prism. You can also see that this one next to it is a prism as well. Prisms have 2 congruent bases. So on this one, the triangle at the top and the triangle at the bottom are congruent, same size and same shape, and they have to be parallel. So if you have a horizontal base on the bottom, you also have to have a horizontal base on the top. So we would say 2 congruent and parallel bases. Now, the other thing, you'll notice there's a second bullet there, is that anything that's not a base has to be a rectangle. So non-bases are rectangles. So this front part here, you can see that this is actually a rectangle. And then there would be a rectangle back here that we can't see and a rectangle back there that we can't see. On a rectangular prism, everything's a rectangle. Then we've got a couple examples of pyramids. Now, pyramids, you will notice, do not have a matching top and bottom. Pyramids have a base, but then up at the other end, the top, there is a single vertex. So we could say faces meet at a single vertex opposite a single base. So you've got the single base, which I've colored in yellow, and then the vertex, the single vertex that we're referring to, would be up here. Another thing is that all of the non-bases on a pyramid are triangles. So if you look here, this is a non-base. This would sort of be like the front of the pyramid for you. That is a triangle. If we look at this one here, the front of the pyramid, that is a non-base. That is a triangle. So all non-bases are triangles. And those are the 2 major things that set prisms and pyramids apart. Prisms and pyramids can both be named based on the shape of the base. The base is a polygon, and polygons are named based on the number of sides they have. So if you have a base with 3 sides, that would be a triangle. Wow, triangle, that's scary looking. Triangle. If it has 4 sides, it might be a square. It might be a rectangle. It also might just go by quadrilateral if it is not if it's not a regular shape, if it's not rectangular. You might have something that's got a parallelogram base, or you might have something that's a rhombus base. Most of the time we highlight squares, rectangles, and then just maybe go to quadrilateral. If it has 5 sides, that would be your pentagon, called pentagonal when we turn it into an adjective. 6 sides would be a hexagon, or hexagonal when we turn it into an adjective. 7 sides, heptagon, heptagonal when we turn it into an adjective. 8 sides, octagon, or octagonal. 9 sides, nonagon, or nonagonal. That's a fun one. And 10 sides is decagon. Decagonal? I don't think I've ever said that word before out loud. All right. Then we're going to look at some of these funky ones. Name the following figures. A figure made of 2 congruent octagons. So I'm like, okay, I've got 2 octagons, 2 8-sided shapes, and everything else is a rectangle. Well, that automatically tells me it's a prism, right? If everything else is a rectangle, that tells me it's a prism. And we name it for its bases. The 2 congruent octagons, those are the bases. So we would name this an octagonal prism. The bases are octagons, and because all the other sides are rectangles, we would call it a prism. A figure made of 1 pentagon and 5 congruent triangles. So you've got a single pentagon, and if everything else is a triangle, that tells us it's a pyramid. So 1 pentagon would make it a pentagonal pyramid. And yes, it is that easy. If everything else is a triangle, pyramid. If everything else is a rectangle, prism. There are some other solids that are not polyhedrons, and these solids, you'll notice, all contain curves. So the first one has a circular base on the top, circular base on the bottom, and then it has a single rectangle that wraps around it. That makes it a cylinder. This one has a single base that is a circle, comes up to 1 point. You'll notice it kind of looks pyramid-like, but it is a cone because it consists of a circular base. And last but not least is the sphere, which could be a baseball, a basketball, anything like that. Why are these other solids not polyhedrons? Because they have curved edges. We can't make them out of just polygons because they have curved edges. Which other solid is the most like a prism? Well, we said the cylinder has 2 bases. And which other solid is like a pyramid? We said the cone has a singular base and meets at a single vertex up at the top. So if we wanted to label that like we did before, it has that one single vertex up here at the top. Now, a net is your other option. If you are struggling to see what these shapes would look like and count their faces, edges, and vertices, you might draw what's called a net. A net is where you flatten the shape. If you were going to punch out a pattern for a cereal box out of a flat sheet of cardboard and then fold it up, what would it look like flat? That's going to be, for example, a rectangular prism. We're going to do a triangular prism. Well, in order to do a triangular prism, you'd have to think about it's got 2 triangular bases, and one's on the bottom and one's on the top. Those triangular bases are connected by prism, right? So connected by rectangles. And then since a triangle has 3 sides, it's going to take 3 rectangles to connect them. The other one on here that's a prism down here is hexagonal prism. So let's do the same idea, right? Hexagon. And then on the other side, a hexagon. And then we've got to connect them with rectangles. So there's a single rectangle connecting my hexagon bases. And then how many rectangles do I need? Well, a hexagon has 6 sides, so I'm going to need a total of 6 rectangles. Now, it doesn't matter how many go above and how many go below, as long as you come out with 6. 1, 2, 3, 4, 5, 6. Now, there is one other way to draw the prisms, and that is you can have, and I just think this one kind of looks goofy to me, but it works. You can do the hexagon, and then you can have a single rectangle sticking off of each side of the base. Looks almost like a flower. And then you just have to remember off of any one of those to put one more hexagon for the other base. So there are multiple options here. Same with the pyramid. So next I'm going to do a pyramid. The pyramid, the easy way actually kind of mimics this last one I just did. So pentagonal pyramid, you're going to want to do the pentagon first, 1, 2, 3, 4, 5, and off of each of those sides, a triangle. Because if it is a pyramid, all of the non-bases are triangles, and you get sort of that same flower shape, but your base is a pentagon. Octagonal pyramid is going to be an octagon. And then off of each of those 8 sides would be a triangle. Now, we know those triangles would come up to a point. And if they come up to a point, that would give you the vertex at the top of your pyramid. Now, we're just looking for a sketch. So you could have much larger triangles than these, and they would have to be larger in order to come up and make a pyramid. But this is just a quick sketch. The other option, which I like a lot less, is if you were to do your pentagonal base, and then you have a triangle sticking off of it, and you sort of attach all of the triangles to each other. I am struggling here with drawing this. And they all kind of 1, 2, 3, 4, 5, sort of like, I'm just trying to think of a reason why you'd want to do it that way, and I really can't, but that's me personally. But you can do it where all 5 of the triangles are connected and then a single base sort of sticking off the side. So here we go. Faces, 1, 2, 3, 4, 5. That's easy to do with a net. Faces, 1, 2, 3, 4, 5, 6. Edges, that becomes harder with a net. On a triangular prism, you're like, okay, there's a triangle on the top, there's a triangle on the bottom, and then I'm going to connect them. Well, that means 1, 2, 3 edges, 1, 2, 3 edges, and then connecting them 1, 2, 3 edges for 6. I have a lot easier of a time doing edges and vertices when it is a 3-dimensional drawing. Vertices, 1, 2, 3 on the bottom, 1, 2, 3 on the top. Oh, I wrote 6 and I counted 9. Goofy me. Edges. So on here, I don't think pyramids are as bad. 1, 2, 3, 4, 5 are on the bottom. And then think about the ones going up the sides. There'd have to be another 1, 2, 3, 4, 5 going up the sides. Vertices, you're going to have 1. Let me change to orange here so you can see it. 1, 2, 3, 4, 5 are on the bottom. And then you'd have the one at the very top. So that would make 6 vertices. Again, over here, 1, 2, 3, 4, 5, 6, 7, 8 around the bottom, plus 1 at the top. So that's not as bad. Like vertices, not terrible on a pyramid. Over here, you're going to have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Faces. I can count the faces. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. It's the edges that are tough. The edges are harder to do unless you can sort of picture it 3-dimensionally. So on this one, I'm going to have 8 edges around the bottom and then 8 edges that lead up to the top, 16. Here, I'm going to have 6 around the bottom, 6 around the top, and then 6 connecting the top to the bottom, which makes 18. And I did the same thing again, vertices, hexagonal. 6 around the bottom, 6 around the top. That makes 12. I know I said 6 and 6, and then I wrote 6. So I know we're going to have to go over these again. The creating of the net, I think not too bad. But if I'm trying to do faces, edges, and vertices, personally, I find it a lot easier to do with a 3-dimensional shape.